All right, we got a big old example now that's going to tie everything together. Okay, so we got a titration. We're slowly adding a base this time, magnesium hydroxide, to a 40 ml sample of a strong acid with 0.25 mole per liter concentration. 3 trials. We're using bromothymol blue as the indicator. Okay, and the whole point is to determine that concentration of magnesium hydroxide. So this is as complicated as an example can get. So just follow along. There's a couple of wrinkles here, but it's still not too bad. And I think you're going to find that redox titrations are always a little more complicated. All right, so I've given you burette readings. We filled the burette 50 mils. The volume went down because we added some. And notice that becomes our burette reading for the next trial. What you really need to know is how much was added. So just subtract those and you'll get, in this trial, 11.9 milliliters is added. Okay. In this trial, it looks like 11.7 milliliters was added. And in this one, it looks like 12.4 milliliters. The reason we do several trials of a titration is to just get a better value, a more accurate value of this volume added, okay, to get a better idea of that unknown concentration. All right. Hey, let's notice the colors here. We discussed bromothymol blue as an indicator in the previous video. Green is the sweet spot. Blue is the color bromothymol blue in a basic solution. Also notice we added a little bit more magnesium hydroxide in this trial and turned the color blue. That's going to tell us that this trial didn't go so well. Okay, so we're going to totally ignore that trial. These two are good. We're going to take the average volume added, and that's really easy. Just between those, it's going to be 11.8 milliliters. So that's what we're going to use in our calculations. Okay. As always with strong acid, strong base, the reaction is just a 1-to-1, producing 2 moles of water. So in this case, we're going to find the number of moles of hydroxide. It equals the number of moles of hydronium, which we're going to be able to figure out from volume concentration. So let's do that right now. Oops. Okay. Oops. Okay. So we have 0.01 moles of hydronium. 1-to-1 ratio here means that that is also the number of moles of hydroxide. The concentration of hydroxide is going to be this number divided by the volume. The volume we use is our average volume. Just remember to divide that by 1,000. Okay, I get 0.847 moles per liter. All right, now let me clean this up. This was the concentration of hydroxide. Awesome. But I think I'm trying to confuse you a little bit. We were adding magnesium hydroxide. Okay. It's in solution. Ionic compounds in solution dissociate. So I'm going to use some space over here to show you what's going on, because there is going to be a molar ratio to worry about. Magnesium hydroxide is going to become magnesium ions and 2 hydroxide ions. Okay, we found the hydroxide concentration, but that's not going to be equal to the magnesium hydroxide concentration because there is a molar ratio here. Okay, the magnesium hydroxide concentration, okay, is going to be this value times the molar ratio desired over given. We know the hydroxide, we're looking for magnesium hydroxide. Okay, so that's going to be 1/2. So like I said, a lot of twists and turns. This is as complicated as it can possibly get with an acid-base titration. And that's when you have to consider a dissociation Okay, it'll always be of hydroxide, and it won't be any worse than this. I'm going to show it all to you again. I got a real mess of a page, but if we go through it step by step, it's not too bad. So we got the volume of titrant added. We eliminated this trial because we went past the equivalence point. All right, these were good. Took the average, found the number of moles of hydronium, which is equal to the number of moles of hydroxide. It's a 1-to-1 molar ratio, always is. Okay, this concentration was hydroxide. Okay, because it's based off the number of moles of hydroxide. But magnesium hydroxide has 2 hydroxides in it, so its concentration was half the concentration of hydroxide. I hope that makes sense. It looks really great. Everyone's doing really well. We're getting close to the end of this weird semester. Good luck, people. Test is coming up next week. More information to come.